All right, we're live. Does anyone have any questions?
I feel like, I don't know if I was just not focusing very well, but I feel like this section was a little bit more confusing.
Yeah.
Is this the one where we use the
Central limit theorem and law of large numbers?
Yeah, that too. I guess there was a lot of definitions, but didn't we do like that little like graph thing where we like did a simulator?
Yes.
Okay.
So I have a question about number 8 on the preparation.
Okay.
Actually, I guess we can just get to that one. Because we have to do number 7 together.
Mm-hmm.
Oh, we do 7 together?
So, yeah.
Oh, I didn't do that together. It doesn't say that.
Well, I think you're just
D.
supposed to compare your answer.
Oh, is that like at a certain part of it? Part D or something? Okay, yeah. I see.
Yeah.
Oh, I need to get my calculator. 1 second.
Okay. See final work today.
Great. That happens every time.
How did you get so popular?
Oh, so we were supposed to take our random numbers, and we all got whatever your mean was. I'm just like reviewing because I got to recap.
Yeah.
And then there's all the possibilities. So it's in a graph. I couldn't like put my dot on the graph, so I just have like a line underneath it. I didn't know how to do that. And then C, does it appear normal? I said mine did because it was within the bell shape, but I think that counts as normal. I don't know what you guys did. Oh, we lost her.
I wasn't sure if I did it right.
Okay.
But I got 43,300 was, that
was your mean?
My mean of the 5 numbers.
Yeah, I got 43,060, and everyone would be a little different because we picked random numbers.
Yeah.
But yeah, you even got really close to my numbers, so. I think it's normal because it fits within the bell shape of the curve. It's not like throwing the curve off.
Okay.
So.
I just said that it didn't really look normal because the sample size was so small, since we were only doing 5 names.
That's true too. That's probably a good point.
I was overachieving and I picked like 3 others just to compare.
Oh yeah.
And they were all over the graph, so I figured that kind of meant that it was not normal.
I'm gonna edit that one. That sounds very smart. I agree with you.
Looks like Maddie said her internet just went out.
No. What? She might. I hate it when that happens. Sometimes it's like emergency run to the library. It's like the worst. Because the sample has to be at least 30, right? Which the initial sample had 30, but our sample only had 5.
Yeah.
Isn't that the law is 30?
I think that's what they said for our class.
So your mean was 43,000.
43,300, I think. Let's see. Yeah, 43.
So we both had similar means. It says to get it from like at least 3 other people, but I guess we just work with what we have.
Yeah.
I wonder if that's likely that it would have been that close together. I feel like other people could have had totally different numbers.
The ones I got were 50,360, 45,460, 47,580. So
Okay,
they're
yeah.
kind of all
They're all over the place. But they're all still within the range of the bell-shaped graph, so. Which makes sense, because that's where all the numbers were in the first place. Okay, and Maddie had a question about 9. Has she updated anything yet with her status? Okay.
Did she say, was it 8 or 9? Wait, I think it was
I thought she
number
said
8.
8 is what she was confused on, but I think I was fine on that part, so I guess we could try to wait till she gets back. Hopefully she does. I mean, sometimes internet
Yeah.
might get a while before she can fix it. Unless she lives close to... She lives in Rexburg, right? So she could just like run to campus, maybe. If she's close by. Well...
Yeah, I wonder what she wanted to talk about with that one.
Did you have any questions on that one?
My question is just, my mind is so full of information from taking, right now I'm in 3 online classes that were probably a lot harder than I've taken since a long time ago. So my brain was kind of overloaded in trying to understand the difference between, I mean, they're emphasizing it so much, the difference between the 2
definitions.
definition, yeah.
Yeah, I took like a bajillion notes, and my paragraph on my notes for that is like huge. And so, I don't know, some different questions I feel like answer different, or my definitions can respond to different parts. So I'm trying to find where my notes were for that. Okay. Basically, the main difference is the central limit theorem describes the shape of it, but the law of large numbers describes the spread of it.
Okay.
So that's one big difference. And I guess by spread, like I get the shape, like bell-shaped or whatever, but the spread makes me just think about how widespread it is or not widespread or something like that. The larger the numbers, the wider the spread, and the larger the sample size probably. But like for both of them, they have to have a larger, I think so. Central limit theorem, the sample mean will be normal if the sample size is large, but if it's not large enough, then the sample mean will not be normal, which I guess that answers why you got that one question right, because the sample size wasn't large enough, what we were just talking about. And then law of large numbers is if the sample size is large, the sample mean should be close to the same and close to the population mean.
Mm-hmm. So would that mean that the spread would be smaller if it was larger, because it would be closer?
What would be smaller?
The law of large numbers, if you had a larger sample size, the spread would be smaller because they would be closer, the distribution would be closer.
I think the spread is actually larger. I That just means that the mean is normal. I don't know if it makes a huge difference in the spread, but because you have, I'm sorry, this has been like a week and a half since I did this assignment. So I'm like trying to process this, and then my brain's all like in shutdown mode. So it's the sample mean and the population mean. I don't know. I know I asked the question somewhere about the spread, but I guess I don't focus too much on that word because it can confuse me. But if you just focus more on the mean, will be more accurate in a law of large numbers rule if the sample size is large, which is the same in the central limit theorem as well, but it'll be approximate. They'll both be approximately normal. But in the law of large numbers, it'll also be close to the population mean, so that's another big difference.
Okay.
Yeah.
Yeah. I kind of know how you feel, except that I'm not sick. I'm just. Yeah.
Yeah. Whew, brain is fried. Okay. I guess for me, I feel like it's Monday morning too, because it's like I just got back for everything, and so I'm just getting into it. But it's actually Tuesday. Should get to leave. Okay. Did you have any other questions?
No, I think I got through all of it.
Like I think I understood it too, but the question is, will I be able to understand it now? Again.
Yeah.
So, okay. Well, let's check back on the email, check back on Maddie, and then I guess we'll just get started on the quiz. Yeah, I haven't heard anything from her.
Maybe she and Nicole can meet.
Yeah, that actually could work. All right, let's start the quiz. You ready?
Let me go.
Oh, did you have any questions on the group homework? Did you do that yet?
I did. I think I finished it without any questions.
Okay, looks like same for me. I'm gonna have to do a lot of like referencing though to remember all that I did. Okay, I'm starting the quiz. I gotta rearrange my screen so I can get the video footage up.
Okay.
Oh man, I lost you. Can't find my screen on the video. There you are.
Okay. So group quiz. For lesson 6. Make sure I'm in the right one.
Yeah, I know. And I get confused because I think it should be the week number too.
Yeah.
Ah. Okay. All right. So we can just take turns. Maddie's back.
Yeah, we'll see how long this lasts.
I guess you could run to campus if you needed a stronger internet connection. You live close to campus, right?
I'm actually in Utah.
Oh. Okay, Nicole is in Idaho then, huh?
Yeah.
Okay. Well, you can always go to your library. I've had to do that before.
That's true. So what did I miss? Are you guys starting the quiz already?
We just barely opened it, but I know you said you had a question on number 8.
Yeah. So pull it up real quick. So how do we know what the shape of the distribution is? Are we assuming it's a bell shape since the numbers are normal?
Pretty much. All you have to say is if it's normally or not normally distributed. You don't have to say like the specific shape.
Yeah.
Oh, okay. Okay, well, then that's easy enough.
Okay.
Let me pull up the quiz.
Okay. Is everyone into the quiz now?
Yeah.
Maddie, you there?
Yes. Yep.
Okay. So question number 1. Well, question number 3, technically. I just kind of skipped the first 2. When you're taking the sample size of n equals 5, what is the shape of the distribution of means? Histogram when the parent population is right skewed. I feel like that's just right skewed. Is that too easy? The sample size is, well, I guess it doesn't follow the law of large numbers because the parent population, so it might not be close to the parent population, which is right skewed. But how do we know that the sample size we happen to get is not going to be, like, where it's going to be?
Yeah, I think you're right. I think it will be right skewed.
Well, my question is because it's not a large sample size, so it doesn't follow the, it doesn't really work with either central limit theorem or the law of large numbers because there's not a large enough sample size. Because in the large law of large numbers, if the sample size is large, then the mean will be close to the population.
It'll be about
mean.
normal.
And so, which in this case is right skewed, but if the sample size isn't large enough, which it isn't, does that mean it's not going to be right skewed because it's not going to be near the population, parent population? Does that make sense?
I don't know. My thought would almost be it's still right skewed because you're only taking 5 of the numbers, but that does sound
Yeah, and
too
I feel like there's
easy.
not enough to go off of, but
Yeah. Apparently there is because there's only 3 answers.
yeah. Okay, let's do question number 4.
Okay. Should I do that?
Yeah.
When you were taking a sample size of 100, what is the shape of the distribution of means histogram when the parent population is right skewed? I think it would be normal because it's a large sample size.
It's large. Okay, Maddie?
Okay. When you're taking a sample size of 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? Is it just normal again?
I feel like I'm overthinking this.
Yeah.
You're trying to help us see that when it's small, it would still be right skewed, but when it's large, it's going to be normal.
But
Okay.
wait, so it's right skewed? Or is it normal?
Since the sample size is small, I think it would still be skewed right.
But how do we know? Because I mean, the other ones were skewed right, but is this based off the same thing that was skewed right? Because in this particular question, it doesn't say anything about being skewed right.
Oh wait, it says it's normally distributed, so it would be normal. I think.
Yeah.
Sorry.
Okay, when you're taking a sample size of n equals 100, what's the shape of distribution of mean histograms when the parent population is normally distributed? Also normal, right?
I think so.
That's my thought.
I feel like I'm doing something wrong because it's like they're all the same answer.
It's too easy.
Yeah. Well, a lot of this homework assignment was more just like definitions and answering questions than actual math.
Yeah.
Okay.
All right. Is it my turn?
I think it's my turn. When would the distribution of means be normally distributed?
Oh, these are the 2 rules.
Yeah. So let's see which
drawn from a normal population. And the sample size is large.
Drawn from a normal population.
I definitely think the second one is one.
Yeah, the data is drawn from populations normally distributed and sample size is large. But are there multiple actual right answers?
Can right skewed be normally distributed if it's still bell-shaped, but like, well, no.
If the population size is large, I mean the sample size.
Yeah. Then I feel like it would still be normally distributed, just right skewed, right? As long as the sample size is large.
So are we picking both the
So
options
what-
with larges?
Do you think the first one is as well because it's normally distributed even though the sample size is small?
Mm,
I can look back at my notes. Oh, okay. I have some notes here about when the mean is normally distributed. It
Okay.
says if the parent population is heavily skewed, it will require a large sample to be assured it will be normally distributed.
So would we go with the population that's right skewed and the sample size is large?
I think that's the second one, yeah. So the second and the fourth one.
Okay, yeah, I think so.
Okay.
So if the population is normal, then the mean will always be normal too.
Okay.
But if it's not normal, then it won't be normal.
So does that
I'm just
mean the
finding notes
first
that help you.
one's correct?
Huh?
Does that mean the first one's correct as well?
Yeah, I
With the
think
sample size being
so. I
small,
think
but
based off that it is.
Okay, so it's 3 of them, just not.
I mean, the
Right,
third
skewed
one
and-
makes the least sense. So
Yeah.
Yeah.
Okay.
Okay.
Whew.
Now, which of the following gives the best explanation of the central limit theorem? Oh boy. So this one, in my notes, it says if the sample size is large, the population mean will be approximately normal.
yeah, if the sample size is large, the sample mean, and it doesn't deal with the population or the spread. So it just deals with the shape and the mean being normal.
So it's the longest answer? No.
No, it doesn't have to do with the 68, 95, 97.
Yeah.
And I don't think it's the first one because that deals with parent population, which is more law of large numbers instead.
Yeah. So
Or three,
I
so maybe
think-
4?
If the sample
it's
size
4.
is large, the shape
Yeah.
of the distribution.
Yep, it deals with shape.
Yep.
Okay.
Okay. Use the following information to answer the next 4 questions. Okay, let x be a random variable with population mean 10 and population standard deviation equals 6. Suppose a sample of size. I'm sorry, I feel like I'm going to pass out right now. I'm having a hard time reading this.
It's good. Do you want one of us to do it?
Yeah, that'll be good.
Okay.
Just going to write down a little more.
I can do it. So suppose a sample size of 36 is drawn from this population. What is the mean of the distribution of sample means? Is that still just 10?
Yeah, I think so.
I'm slow over here. 1 second. Just processing the question.
Number 10. So number 10 says, what is the standard deviation of the distribution of sample means? And I think that's where we have to calculate, right?
Yes. So that one is 6 divided by the square root of 36. So 1.
Just want to check.
Yes.
Oh, yeah. I gotta
Please do.
find the yeah, so you do the
So
square
it's
root of the mean. No, square root of the standard
Six.
deviation.
divided by
It's square root of the number of n.
Oh, okay.
6.
Yeah.
So
1.
that's what I got, yeah, 1.
Okay.
Wait, what are we dividing it by? The
36, square root of 36.
divided by the square root of 6. Wait, 36 divided by the square root of 6?
Is 1.
Other way around.
Oh, that's why I got a totally weird answer.
Oh, sorry. I didn't
Good.
hear you right, I guess.
1.
Yeah.
And 6 is the standard deviation. Oh, yeah, okay. Just had to make sure I understood too.
Yeah.
Okay. 11?
Yeah.
Yeah.
Let's see, is it Maddie's turn?
Sure. I don't know. Regardless of the distribution of the population, if the sample size is large, meaning n is greater than 30, what would be the shape of the distribution of the sample mean? Normal?
Well, the sample size is less than 30.
Oh. Yeah. No, it's greater.
And
Oh,
is
you're
greater,
right. You're right.
so it would probably
I
be
gotta go back to elementary school. Okay. So yeah, it's normal.
okay. So what theorem would justify your response to the last question?
Law of large numbers.
Yep.
Okay, are we ready to submit this?
Yeah.
Okay.
I'm nervous for this.
Ugh.
All right.
Yay. Oh, we got number 12 wrong.
What? That was the easiest one.
Yeah, apparently not.
I think that's wrong.
Oh, I don't know. I think I keep getting mixed up between the two of those.
No, but law of large
Oh,
numbers
okay.
is the only one that deals with the population mean.
But the central limit theorem talks about if the sample size is large, everything will be approximately normal.
Oh, so I guess I could have.
So, yeah.
But okay.
All right.
Hmm.
Do I want to go back and change that?
Yeah, I'm just gonna get off and do that by myself. But
Okay.
thanks
Yeah.
for coming.
Thanks for meeting me even though you're sick. Hope you feel better.
Yeah.
Yeah, seriously.
Thanks. Well, I'll see you guys normal time Thursday, right?
Yes.
And if anyone hears from Nicole, okay, she's doing. Okay, who wants to be the leader next time?
Fine. Either. Yeah. I could do it.
Okay, you're signed up.
Okay, I'll do it.
Okay, see you guys then.
Sweet.
Thanks.
Okay, see ya.
Bye.
Bye.